Now that you're a bit more familiar with the Discover UI, which shows all the vulnerabilities that were detected in your infrastructure, we have a couple of notes to go through about vulnerability management. So first up is the fact that severity info vulnerabilities really are informational, even though we treat them like normal vulnerabilities that can be resolved, pending, and this and that. Um, they are purely informational, just over there for you to get more information about your infrastructure. Which is not to say that they are, in inverted commas, useless. They are important. For example, the one that we have in this screenshot here is very important for customers that need to adhere to PCI DSS standards. Like for example, version 4 says that you need to know which cipher suites are running in your infrastructure. So most of the time, you can get information by going on the all actions, additional details, and then you get something like this. See? And this is the same for most other info level alerts. So over here you get a list of ciphers that are running on this particular SSH server. Now, the question of false positives. There's always a period of tuning that goes on. Typically after the first couple of scans, the installation is already kind of tuned. Now, there are what we call obvious false positives, and these usually happen in Windows because there is a lack of standards to translate a name like this to an actual CPE, which leads us to a particular vulnerability. So to give you an example, in this particular case, a customer had the actual name of the product was Fortinet SSO Terminal Server Agent, but our AI translated this to FortiTester. It was the closest match it could find. Obviously, these are two very different products, so it's an obvious false positive. In this case, you open a ticket with an issue with support, and CyberSIF support will sort it out for you. So these are obvious false positives, you know. But then there are non-obvious false positives. They are highly dependent on your configuration. So for example, over here, what was detected was OpenSSH version 8.3, and the vulnerability, the CVE description seems to match. It's found in OpenSSH before 9.6. So it seems to match. But it only happens with certain OpenSSH extensions. So you actually need to go through the CVE, then check against your local configuration on a particular server or service, and decide whether it should be closed or mitigated. So it's highly dependent on local configuration, and this is something that you have to work out typically with sysadmins. Now, one of the features of vulnerability management in Tutela is what we call auto-closing. Auto-closing means that the Tutela server agent is, in inverted commas, intelligent enough to auto-close vulnerabilities for you. Typically, this happens when between one scan and another, a vulnerability is not detected in a new scan. So if we go through the logic, a scan gets uploaded, and the CVE is in the old scan, but it's not in the new scan, right? If it is in both the old scan and the new scan, we don't auto-close. Everything it goes on as normal, right? But if it's not in the new scan, then there is some, the CVE may or may not be there anymore, you know, so we may or may not be able to close it for you. Now, if it is a network scan, we need to make sure that the port is still reachable. If the port is not reachable, we cannot tell for sure that the CVE has been closed, so we keep the CVE open. Why? Because it could just be that the service is off or the server is unreachable. But let's say it wasn't a network scan, then it's a host-based scan, you know. If it's a host-based scan, is the software is still installed. If it's not still installed, then the CVE might still be present. And actually, I'm going to update this to make an extra note here, because if it's a host scan and the software is not installed, the CV might still be present because we just haven't detected the software for whatever reason. So we do mark the software as being uninstalled, but we don't close it. But let's say that there is a host scan, the software is installed, and the version number changed. If the version number didn't change, it's probably some other problem, because typically vulnerabilities get resolved on patching, so the version number changed. If it has changed, the version number, then we auto close the CVE. What does auto closing actually look like when you go into the notes of a particular CVE? You get something like this: auto closed by update. Now for CentOS or Red Hat hosts, it would be RHSA. For Ubuntu, it will be a different note. For Windows, it would be a different note, and so on. But you always get auto closed by whatever. So that's about it for this video. If you have any questions, please do let us know.